3D technology has revolutionized many industries. Specifically, architecture and construction has greatly benefited, with technology like CAD and BIM changing the way space is designed and communicated. Virtual reality, or VR, is a more recent development which works with 3D software and has succeeded in its ability to stimulate immersive experiences in computerized environments. VR has been on humanity's radar for some time, experimenting with depth of field and creating false perceptions of reality in paintings. However, it wasn't until the 1900s, when technology became computerized, that this idea was realized. In 1956, Morton Healy created a head-mounted display, also known as HMD, to play static video. Ivan E. Sutherland in 1968 created the first true virtual reality. In Sutherland's design, the images displayed changed according to the viewer's head position. The first VR architectural walkthrough, developed from 1970 to 1985, was at the University of North Carolina. Since the 1990s, VR has been used to support visualization of design, construction, and city operations. Most recently, VR has been reinvented with the release of Oculus in 2012 with a new approach for customers in entertainment and gaming. This release was in HMD and utilized modern graphics and VR together. Since this launch, several other brands have created similar VR headsets, prompting the wider adoption of VR in the architecture and construction industry. To create a convincing experience in a digitized environment, a user's brain must be convinced that the space they're experiencing is real. Head-mounted displays render digital images and are worn by a user. They create the illusion of depth and allow one to look around the space by tilting their head. A lot of setups include gloves or a remote, which help the user to walk around and interact with the space. There are also other VR setups, such as reality centers and cave systems. However, due to the commercialization of the HMD setup, this is most popular and practical for architecture. To create the VR environments, designers utilize 3D modeling and render software. Autodesk Live allows designers to turn their BIM models into VR experiences. Architects can step into their own designs for review and use this delivery mode to communicate to their stakeholders at any point along their design development. Stingray is another software which has the added benefit of being able to edit real-time in the VR environment to make changes to the model. The most common use of VR in the architecture construction industry have been stakeholder engagement and design support. VR has been very successful in its ability to engage all stakeholders, breaking down the barriers of construction jargon. Instead of a client staring at a screen or A3 set of plans, they can step into the proposed design and experience textures, depth, and scale to help imagine how the end product will look and feel. VR also provides professionals with unique information prior to the building completion as to how users experience the space. It has also been used in design support. Architects have the capability to step into their 3D models in VR to build and edit. The end goal of this capability would be for designers to feel as though they are playing God, waving a hand or remote as shapes appear in which they can be edited as they please. The biggest challenge for VR is its gaps in research and development. There are many other uses for VR in architecture and construction, but there is a lack of software to back up these demands. For example, researchers have identified capabilities for VR to provide construction support. This has been applied to high-risk construction operations that have been tested in VR to identify hazards and prevention methods without real danger. In 2020, COVID-19 has forced many workers around the world to work from home. Further developments in VR will be able to virtually transport design and management teams to a worksite with live updates of construction development. Professionals from around the world can engage and develop in a platform to access the currently inaccessible. There is also a big interest in utilizing VR to provide more engaging and educational experiences. In construction and design, it is critical for students to understand how things are built. Through VR, students can experiment and build in a danger-free environment. Whilst there has been a growing use of VR in the architecture and construction industry, the adoption has been slow. Fortunately, there is a strong investment interest in VR, ranking in the top 10 Gartner Strategic Technology Trends for 2019. Currently, technology is the disruptor for this industry and has allowed many great innovations for the built environment. For the future of VR, its many possibilities can be realized and help change the game for design.